So here we have the parabola with the equation y plus 3 whole squared equals to 2 times x plus 2. We need to determine the coordinates of the vertex and the focus, the equation of the axis and the directrix, and the length of the latus rectum of the parabola. Let us begin. So here what we'll do, we'll start with the given equation of the parabola. We have y plus 3 whole square equals to 2 times x plus 2. Now what we'll do, we'll make two substitutions here. We will suppose that let x plus 2 be equals to x in uppercase and y plus 3 equals to y in uppercase, such that our equation now becomes y squared equals to 2 times x. Or what we can do, we can rewrite this as y squared equals to 4 times half times x. Now this is run in this particular fashion because we are going to compare it with the standard form of a parabola y squared equals to 4ax. And this tells us that the value of a is going to be 1/2. What we have done here is our original equation of the parabola. This is expressed in terms of the coordinates x comma y. Now this is going to be our original coordinate system, and after making these two transformation, we can say these two substitution, we have converted our parabolic equation into a form which is going to be considered in the new coordinate system. So this is the new coordinate system, and what we'll do, we'll try to sketch the graph of y squared equals to 4ax, and from the standard equation of the parabola we can easily define the coordinates of the vertex, focus, the equation of the axis and directrix, and the length of the latus rectum. And once we have those values, we can use these two transformation formula to revert back to the original coordinate system. So let us begin. So here we have the graph of the parabola y squared equals to 4ax. The coordinates of the vertex of this parabola is going to be at the origin. The coordinates of the focus is going to be at a comma 0. Now the straight line on which the vertex and the focus of the parabola lie, that line is referred to as the axis of symmetry line. And since this line is along the x-axis, its equation will be given by y equals to 0. Then we have another point on the axis of symmetry line. Let's call that point B. B has the coordinates negative a comma 0. That means we are choosing the value of point B in such a way such that the distance of point B from the vertex, that this is the vertex, is exactly equals to the distance of the focus from the same vertex, meaning this length is exactly, let's call it d, this length is exactly going to be equals to this length d. Now through this point B, we're going to pass a straight line which is perpendicular to the axis of symmetry, and this line is referred to as the directrix of the parabola. Now we know any line which is parallel to the y-axis, its equation is given by x equals to a. Now in our case, we have x equals to negative a because a corresponds to the x coordinate of the point through which the directrix line passes. Since the x coordinate is negative a, so we have x equals to negative a, representing the equation of the directrix. And then we have the latus rectum. The latus rectum is the straight line that passes through the focus of the parabola, and it is perpendicular to the axis of symmetry line with its endpoints on the parabola. So now we have the standard form of the parabola. So let's work with a problem. So we work with a new coordinate system. So this is the new coordinate system x comma y, where the vertex of the parabola is at the origin 0 comma 0. This means that x value equals to 0 and the y value that's equals to 0. But we want to go back to the old coordinate system or the original coordinate system x comma y. All you have to do is use the same two equations, x equals to 0 and y equals to 0, but in place of x, we're going to use x plus 2. Where x plus 2 equals to 0. And then in place of y, we replace it with y plus 3, but this will be equals to 0. So when we solve for x and y, we get the coordinates of the vertex in the old coordinate system. So that's going to be negative 2 comma negative 3. Coming to the focus of the parabola. So focus of the parabola according to the new coordinate system, that's a comma 0. So here a corresponds to the value 1/2. So we have 1/2 comma 0, meaning the value of x equals to 1/2 and the value of y that's equals to 0. Now in the old coordinate system, we'll take x equals to half but replace the value of x with x plus 2. So with x plus 2 equals to 1/2. And then we have y equals to 0. That means y plus 3 equals to 0. So when we solve for the value of x and y, so x will be equals to -3/2 comma -3. So that's going to be the coordinates of the focus of the parabola in the old coordinate system. Then coming to the equation of the axis in the new system, that's y equals to 0. So in the old system, that's going to be y plus 3 equals to 0, which means y will be equals to -3. Then we have the equation of the directrix of the parabola. The directrix of the parabola has the equation x equals to -a. So a here is 1/2. So x equals to -1/2 is the equation of the directrix. But we want to go to the old system. So x plus 2 will be equals to -1/2, which means x will be equals to -5/2. And then finally, we obtain the length of the latus rectum of the parabola. So length of the latus rectum will be absolute value of 4 times a. So here a will be 1/2. So that means the length of the latus rectum will be 2 units. Now this is independent of the coordinate system that we choose. So be it the old system or the new system, the length of the latus rectum is always going to stay as 2 because that talks about the shape of the parabola. So we have successfully obtained the coordinates of the vertex of the parabola. So that's going to be at -2, 3. Coordinates of the focus will be at -3, 2, -3. Equation of the axis will be y equals to 3. Equation of the directrix will be x equals to -5/2. And the length of the latus rectum will be 2 units for the parabola given by y plus 3 whole squared equals to 2 times x plus 2.